cannon is shot with a velocity of 450 meters per second at a height of 60 meters. Calculate the time it takes for the cannonball to hit the ground and calculate the distance away from the cliff the ball landed. So to get started, let's draw a picture. What's happening? So here's my cannon. It's shooting a ball, and the projectile is going to look like this. It's going to look like an arc. So it's going to land a certain amount of distance away from the cliff. This is what we want to know. So if I have my cannonball, the cannon is only shooting in the x direction. So our VIX is only going to be in the x direction. The cannon is not shooting downwards, it's not shooting at an angle, it is shooting horizontally. Therefore, all of the initial velocity is going to be in the x direction. Why the ball is falling is because of gravity. Gravity is only pulling you downwards, it's not pulling you side to side. Therefore, the acceleration due to gravity is only going to be in the y direction. So for these problems, it's really important to separate your x's and your y's really, really neatly. That way you're not confused when you're plugging into the equation. So to do this, I'm going to erase my beautiful picture. I'm an artist. And I'm going to separate all my components for the x and the y. So this chart's going to help me stay organized. And it's also going to allow me to see all my variables so I know which formula to use. So let's start with our x direction. The cannonball only shot horizontally, therefore all of that initial velocity is going to be in the x direction. And the reason I'm doing VIX is that way I know that this is my initial velocity in the x direction. I'm going to do the same thing for my y, so I'm going to be on y. The cannonball is not shooting downwards, therefore all of the initial velocity is in the x direction, and there's none in the y direction. The cannonball is falling because of gravity, so that means our acceleration is going to be at gravity, which is 9.81 meters per second squared. The gravity is only pulling up and down, not side to side. So that way, so we know that our acceleration in the x direction is going to be 0. There's no acceleration in the x direction. We have our height. Height is vertical, so that's our distance in our y direction. The height of the cliff is 60 meters. For part B, part 2, we're solving for the distance in the x direction, how far away it is. So that's one of our unknowns. So let's start with part 1, where we want to know the time. So the time is going to be the same in the x and the y direction. So once we find time in one direction, we can apply it to the other direction. So we've got 4 givens. 1, the x, we're missing 2, the y, we're missing 1. So in order to calculate the time, we're going to be using the y direction variables because we're only missing one variable. For the x direction, we're missing both distance and time, so we can't calculate the time using the x direction. So let's look at our formulas and let's pull out the one that matches our variables. We have VI, A, D, and T. So we're going to be using our D is equal to VIT plus 1/2 AT squared. When you plug in your variables, please be extra careful in only using your y givens and not your x givens. So that's why it's really important to separate the x and the y so you're not getting confused with all this information. So we have D is 60, VI is 0 times our T plus 1/2 gravity, 9.81 T squared. 0 times T is going to be 0, so let's get rid of that. And we're left with 60 is equal to 1/2 9.81 t squared. So let's multiply 1/2 and 9.81. So 60 is equal to 4.9 t squared. Divide by 4.9. Divide by 4.9. So we have 60 divided by 4.9 is 12.24 is equal to t squared. Got to square root both sides, and you are left with 12.24, 3.5 seconds. So we have our t is equal to 3.5 seconds. So that's the answer to part 1. So now we can erase our t as a question mark. And now we know that our t is 3.5 seconds. And it's also 3.5 seconds in the x direction. So now we're only missing one variable in the x direction. So I'm going to erase all of this so I have room to do my second calculation for part B, part 2. So we have VI, A, D, and T. So again, we're going to use the same formula. Now we just have to be careful that we're only using our x direction variables now. So we already did the y, now we're going to do the x. So we're looking for our distance. Our VI is 450 times t, which is 3.5 plus 1/2, 0, 3.5 squared, that's 3. So since our acceleration is 0 in the x direction, this whole second term, 1/2 times 0 times 3.5 gets canceled out. Boom, that's 0. So we're left with d is equal to 450 times 3.5. Now we do some math in our calculator. 450 times 3.5, and our distance is 1,575 meters. And you're done. So the trick here is to be careful of your x and y variables, separate them and make yourself really organized, and then just following the steps that we've been doing for free fall and kinematics.